Dear students of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today, behavior of function and sketching its graph. Now we'll start with the increasing and decreasing of a function. Definition: if f of x2 greater than f of x1, where x2 bigger than x1 for all x1 and x2 belongs to the open interval a and b, in which the function f is defined, we say that f is an increasing function on the open interval a and b, because x2 bigger than x1 and f of x2 bigger than f of x1. And if f of x1 smaller than f of x2, where x2 bigger than x1 for all x1 and x2 belongs to the open interval a and b, in which the function f is defined, we say that f is an decreasing function on the open interval a and b. From the graph, x2 bigger than x1, but f of x2 smaller than f of x1, so the function in this case is decreasing function. Now we can deduce the following theorem using the first derivative to find the increasing and decreasing intervals. Theorem: let the function f of x is differentiable function in the open interval a and b. In the case of increasing, number one, if f of x is increasing on this interval, then f dash x bigger than 0 for all x belongs to the open interval a and b. Number two, if f dash x bigger than 0 in the open interval a and b, then f of x is increasing on this interval. In the case of decreasing, let the function f of x is differentiable function. And number one, if f of x is decreasing on this interval, then f dash x smaller than 0 for all x belongs to the open interval a and b. Number two, if f dash x smaller than 0 in the interval open interval a and b, then the function f of x is decreasing on this interval. Example: find the intervals of increasing and the intervals of decreasing for the function f, where f of x equals x to the power 3 minus 9x to the power 2 plus 24x minus 1. Now we have the function f of x equals x to the power 3 minus 9x power 2 plus 24x minus 1. What is the first derivative of this function? The first derivative is f dash x equals 3x power 2 minus 18x plus 24. Now put f dash x equals 0. Then 3x power 2 minus 18x plus 24 equals 0. Divide by 3. We get x power 2 minus 6x plus 8 equals 0. By factorize this expression, we get two brackets, x minus 2 between two brackets multiply x minus 4 between two brackets equal 0. Then x equals 2 or x equals 4. Now we can draw number line from negative infinity to infinity and discuss the sign of the first derivative f dash x and the behavior of the function f of x. We have three intervals. The first interval from negative infinity to 2 open, and the second interval to 4 open, and the third interval 4 and infinity open. Now, when x equals 2, the first derivative f dash x equals 0. When x equals 4, f dash x equals 0. And what is the value of y or f of x at x equals 2? F of x at x equals 2 equals 19. And at x equals 4, y or f of x equals 15. Now, what is the sign of f dash x in each interval? In the first interval from negative infinity, and 2 open, the sign is positive. And the function is increasing in this interval. In the open interval 2 and 4, the sign of f dash is negative and the function is decreasing in this interval. In the last interval, open 4 and infinity, the sign of f dash x is positive and the behavior of f of x is increasing function. How we can get the sign positive or negative in these intervals? By substitution in f dash x, by choose a number belongs to this interval. Now, in the open interval, negative infinity and 2, we can choose any number belongs to this interval, like 1. Then f dash 1 equals 3 multiply 1 to the power 2 minus 18 times 1 plus 24, which equals 9. 9 is a positive value. Then the function is increasing in this interval. Another interval, in open interval 2 and 4, we can choose the number 3 belongs to this interval. Then f dash 3 equals 3 multiply 3 to the power 2 minus 18 times 3 plus 24, which equals negative 3. Negative 3 is a smaller than 0 negative value, then the function is decreasing in this interval. In the last interval, open interval 4 and infinity, f dash 5 equals 3 multiply 5 to the power 2 minus 18 times 5 plus 24 equals 9. 9 bigger than 0 or positive value, then the function is increasing in this interval 4 and infinity. Now we have 2 points. 2 and 19 is a critical point, and 4 and 15 is a critical point. Then we have 2 critical points at x equal 2 and x equals 4. The value of y in the first point is 19, and the value of y in the second point is 15. Another example. Find the intervals of increase and the intervals of decrease for the function f, where f of x equals 5 minus 2 e to the power 2x. We have f of x equals 5 minus 2e to the power 2x. And the domain of this function is the real numbers r. And f dash x equals negative 4e to the power 2x, because the derivative of e power 2x is 2 multiply e to the power 2x. And we have coefficient of e power 2x is negative 2, then f dash x equals negative 4e to the power 2x. Put f dash x equals 0, then negative 4e to the power 2x equals 0. The equation has no solution in R, because e to the power 2x always positive. Multiply negative 4, then this equation always negative. Then f dash x smaller than 0 for each x belongs to R, then the function is decreasing on its domain R, because f dash x negative or less than 0. We move to the next example. Find the intervals of increase and the intervals of decrease for the function f, where f of x equals 3 minus log x to the power 2 to the base e. We know that log x power 2 to the base e is ln x to the power 2. Now we have the function f of x equals 3 minus log x power 2 to the base e, and the domain of this function is R except set of zeros. What's the derivative of this function? The derivative is f dash x equals negative 2 over x. Put f dash x equals 0, then negative 2 over x equals 0. This equation has no solution in R, because negative 2 over x, where x belongs to R except 0, always not equal 0. Now we can deduce the behavior of f of x by using the number line from negative infinity to infinity. When x equals 0, f dash x undefined, and f of x is undefined, because the domain of the function and the derivative of the function is R except 0. Then x equals 0, undefined at f dash x, or f dash 0 undefined, and f of 0 undefined. What is the sign of f dash x in the open interval negative infinity and 0? The sign is positive, and the function is increasing in this interval. What about the open interval 0 and infinity? F dash is negative, and the function is decreasing in this interval. We can get the sign of f dash by substitution in f dash x. The first interval in the open interval negative infinity and 0, we can choose number like negative 1, then f dash negative 1 equals negative 2 over negative 1 equals 2, 2 bigger than 0 or positive number. Then the function is increasing on this interval negative infinity and 0 open. In the open interval 0 and infinity, we can choose number like 1, then f dash 1 equals negative 2 over 1 equals negative 2 smaller than 0 or negative number, then the function is decreasing in this interval. Next example. Find the intervals of increase and the intervals of decrease for the function f, where f of x equals x plus 2 sine x, where x bigger than 0 and smaller than 2 pi. The function f of x equals x plus 2 sine x. This function is continuous and differentiable on the open interval 0 and 2 pi. What is the derivative of this function? F dash x equals, the derivative of x equals 1 plus derivative of 2 sine x is 2 cosine x. Now put f dash of x equals 0, then 1 plus 2 cosine x equals 0, and hence cosine x equals negative half. We know that cosine x equals negative, then the angle in the second or third quad, because cosine x positive in the first and the fourth quad. Then x equals 2 pi over 3 or x equals 4 pi over 3, and x belongs to the open interval 0 and 2 pi. The two angles belongs to this interval. Now we can deduce the behavior of the function f of x by using the number line. When x equals 2 pi over 3, f dash x equal 0. And when x equals 4 pi over 3, f dash x equal 0. What about the sign of f dash x in these intervals? In the first intervals, f dash x is positive and the function is increasing. The second interval, f dash x is negative and the function is decreasing. In the third interval, f dash x is positive and the function is increasing. We can get this sign by substitution in f dash x. In the open interval 0 and 2 pi over 3, we can choose the angle pi over 2, then f dash pi over 2 equals 1 plus 2 cosine pi over 2. We know that cosine pi over 2 equals 0, then f dash pi over 2 equals 1 plus 0, which equals 1, and 1 is a positive number bigger than 0, then the function is increasing in this interval. In the open interval 2 pi over 3 and 4 pi over 3, we can choose x equals pi. Then f dash pi equals 1 plus 2 cosine pi equals 1 plus 2 multiply cosine pi, which equals negative 1. Then f dash pi equals 1 minus 2 equals negative 1. Negative 1 is smaller than 0. Then the function is decreasing in this interval. In the interval 4 pi over 3 and 2 pi, we can choose x equals 3 pi over 2. Then f dash 3 pi over 2 equals 1 plus 2 cosine 3 pi over 2. Cosine 3 pi over 2 equals 0. Then f dash 3 pi over 2 equals positive 1. Positive 1 bigger than 0. Then the function is increasing in this interval. Now, dear students, we can deduce the following concept. What is the critical point? Definition. We say that the point x1 and f of x1 is a critical point of the function f if one of the following satisfies. Number 1, f dash x1 exists and is equal to 0. Then the first condition, f dash x1 exists, have a value, and the value equal 0. Then the point in this case is a critical point. Number 2, f dash x1 doesn't exist or undefined, then we say that the point x1 and f of x1 is a critical point in in two cases. The first case f dash x1 equals 0, second case f dash x1 undefined. Now we move to the next example. Choose the correct answer from those given in the curve if the curve of the function f, where f of x equals ax power 2 plus 12x plus 1, has critical point at x equal 2, then a equals 12, negative 3, negative 6, or equal 3. Now we move to the next example. Choose the correct answer from those given the greatest value of the function f, where f of x equals 4x minus x to the power 2 is, where x belongs to R, is 4, 8, 16, or 32. The function f of x equals 4x minus x to the power 2, and the first derivative f dash x equals 4 minus 2x, and the second derivative f double dash x equals negative 2, which is less than 0. Put f dash x equals 0, then 4 minus 2x equals 0, and 2x equals 4. Then the value of x equals 2. What is the value of the second derivative at x equals 2? The second derivative, f double dash 2 equals 0. Then the function has local maximum value at x equals 2, and f of 2 equals f of 2, the value of y, f of x at x equal 2 equals 4 multiply 2 minus 2 to the power 2, which equals 4. Then the greatest value of the function f is 4, and we can choose the letter a, which equals the greatest value of the function f, which equals 4. Last example today. Find the local maximum and the local minimum values of the function f, where f of x equals x to the power 4 minus 4x to the power 3 plus 4x to the power 2 minus 15. Now, the function f of x equals x to the power 4 minus 4x to the power 3 plus 4x to the power 2 minus 15. The first derivative f dash x equals 4x power 3 minus 12x to the power 2 plus 8x. And the second derivative f double dash x equals 12x to the power 2 minus 24x plus 8. Now put f dash x equals 0, then 4x to the power 3 minus 12x to the power 2 plus 8x equals 0. By taking 4x as a common factor, then 4x multiply between two brackets x power 2 minus 3x plus 2 equals 0. By factorize the bracket, we get 4x multiply between two brackets x minus 1 multiply between two brackets x minus 2. This expression equals 0. Then the values of x equals 0, or x equal 1, or x equals 2. Now, by using the second derivative test, we can find f double dash 0. F double dash 0 equals 12 multiply 0 to the power 2 minus 24 times 0 plus 8, which equals 8. 8 is a positive number greater than 0. Then the function f has a local minimum value at x equals 0. When the second derivative is positive, then the function has local minimum value at x equals 0. What is this value? We can substitute by x equals 0 in the original equation, original function. F of 0 equal 0 to the power 4 minus 4 times 0 power 3 plus 4 times 0 power 2 minus 15, which equals negative 15. Negative 15 is the local minimum value. Now, what about the critical point at x equal 1? F double dash 1 equals 12 times 1 power 2 minus 24 times 1 plus 8 equals negative 4. Negative 4 smaller than 0. Then the function f has a local maximum value at x equals 0. Now, what is the value of y when x equal 1? F of 1 equals 1 to the power 4 minus 4 times 1 to the power 3 plus 4 times 1 to the power 2 minus 15 equals negative 4. Negative 4 is the local maximum value. What about the critical point at x equal to f double dash 2 equals 12 times 2 power 2 minus 24 times 2 plus 8. F double dash 2 equals 8, positive number greater than 0. Then the function f has local minimum value at x equals 2. What is the value of the local minimum value? F of 2 equals 2 to the power 4 minus 4 times 2 to the power 3 plus 4 times 2 power 2 minus 15 equals negative 15, and negative 15 is the local minimum value. And by this example, we come to the end of our program today, and till we meet again, it's